Hey guys, this is Mrs. Rooker. Today we are talking about inverse functions. And the first thing we're going to define is the inverse relationship. So an inverse relationship is switching x and y. And then an inverse function is the same idea, but it's only a function if it passes the vertical line test, or if every input has one and only one output. Each input has one and only one output. Or I'm going to write that it passes the vertical line test. We'll talk more about this later. You don't need to stress about that too much right now. Vertical line test, which I'm sure you've heard of before, but we'll talk about it more. All right, to find an inverse, you switch x and y, and then you solve for y. So that's the real big important thing that you need to know, is to find the inverse today. You're going to switch x and y, and you'll solve for y. So, inverse. Switch x and y. So x goes here, y goes here, and we solve for y. To solve for y, I add 4 to both sides. I get x plus 4 equals 7y. Then divide both sides by 7. Y equals x plus 4 over 7. And that is our inverse. Moving on to number 2. Same idea, switch x and y. Well, it's not written as such, but that's the y. When we switch x and y, that'll now be x equals 2/3 y plus 6. Subtract 6 from both sides, we get x minus 6 equals 2/3 y. All right, now we need to multiply by the reciprocal to get rid of 2/3. So actually, I think what I'm going to do is just multiply everything by 3 and then divide everything by 2. If I multiply everything by 3, that'll cancel out this 3. So this will be 3x minus 18 equals 2y. Now I just divide everything by 2. If I divide this first one by 2, it's 3 halves x, 3x over 2. And then I can divide negative 18 by 2. That's just going to be negative 9. So I can separate those and divide each by 2 separately. Right, so this here, oh, didn't mean to draw a line through it. Sorry, my computer's a little glitchy right now, and it's not letting me erase that. Okay, there we go. That's, dang it. That was supposed to be 3x over 2 minus 9. So that's my answer. Sorry about that. All right, switch x and y, solve for y. X equals 3 over y. When I have to solve for y and it's in the denominator, I first have to multiply both sides by y to get it out of the denominator. So I multiply both sides by y. These will cancel. We'll get yx equals 3. And then last step to solve for y, divide both sides by x. So y equals 3 over x. So you're getting some good algebra review practice here. Alright, moving on. Why don't you try this next one on your own? Pause the video, and when you unpause, I'll have the solution up here for you. I decided to start recording early because I realized this was a little bit tricky. So I did part of it. I subtracted 4 from both sides, and now I realize that y is on the denominator. Remember, I need to get y out of the denominator first, so I multiply both sides by y. I'm not actually going to distribute y in there though. I'm just going to leave this as y times x minus 4 equals 5. And then my last step is to just divide away that x minus 4 so that y can be by itself. So it'll be y equals 5 over x minus 4. And that will be the inverse. Final one in this section, this is a y for our purposes. We'll switch x and y. X equals y squared plus 4 and solve for x. So subtract 4 from both sides. We'll have x minus 4 equals y squared. And then to solve this, we need to get rid of the squared, so we square root both sides. Really important. Don't forget, whenever you square root or solve by square rooting, put a plus or minus in front. Anytime it's an even root. So my answer is going to be plus or minus square root of x minus 4. That plus or minus is really important. All right. Vocabulary. Verify an inverse function. If two functions are inverse functions, then their composition will be x. So what that means is if we plug one function into its inverse and we simplify it, it should simplify to just x. Everything else should cancel out or simplify, whatever. So if we plug the inverse into the function, we should get x, and vice versa. If we plug the function into its inverse, we should also get just x. So it says to verify that the functions are inverses. So based on the wording, I'm assuming they are inverses, and we're trying to just prove or show that they are. So I'm going to plug one into the other, and I should get x as an answer if they are inverses. So when I plug one function into the other, I'm just going to plug the inverse into the original f of x. So the 4 is still there, and instead of x, I'm replacing that with 1/4 x plus 3/4. So that was instead of my x, but then I still have minus 3 on the end. So I just replaced my x with the inverse. Now I need to simplify this, and hopefully I get x as an answer. Distribute 1/4 x times 4. The 1/4 and the 4 cancel. I just get x. 1/4 times 3/4. Well, the 4 on top cancels with the 4 on bottom, so I would be left with just plus 3. And then I have this minus 3 on the end. Well, combine like terms, the positive 3 and the negative 3 cancel, we get x. So that proved that those were in fact inverses of each other. Let's try the next ones. I am not so confident that these are actually inverses of each other. So we'll plug in and we'll see. Doesn't matter which one we plug in to the other. So I'm just going to plug this one into this one this time, just so it's different than how we did it the last time. So I write the 5, but instead of this x, I'm going to put 1/5 x plus 5. 5 times 1/5, those will cancel, we'll get just x. But then we have 5 times 5 is 25. That's no good. Not inverses. So if we get just x as an answer, I probably should have put this. Yeah, they are inverses because I got x on the first one. All right, so number 8, find the inverse and then show that the composition of the two yields x. So find the inverse and then basically prove that they are inverses by plugging one into the other and getting x. So switch x and y. So it'll be x equals y cubed plus 1. Subtract 1 from both sides. X minus 1 equals y cubed. And then cube root both sides. We get that y equals cube root of x minus 1. Don't need a plus or minus on odd roots. Alright, so that's our inverse. I'm going to plug that inverse into the original function. So instead of x, I'm going to put cube root of x minus 1. But then it said we wanted to cube it, and then plus 1. So I plugged the inverse into the original function. Remember, cube and cube root cancel each other out, so I'm left with just x minus 1. And then I have the plus 1 on the end. The negative 1 and the positive 1 will cancel, and I'll get just x, which is awesome. That confirmed that what I got was in fact an inverse. Alright, so this is just more of the same, except these are all power functions, meaning they all have exponents. Switch x and y. This will be x. 1/4 y cubed plus 3. Subtract 3 from both sides. X minus 3 equals 1/4 y cubed. We want to get rid of the 1/4 next. We want only the thing that's being cubed to be on the one side before we cube root it. So to get rid of a 1/4, we multiply by the reciprocal. The reciprocal of 1/4 is 4. 4 over 1. So we multiply both sides by 4. Multiply that by 4. Those will cancel. Multiply this by 4. We get 4x minus 12 equals y cubed. Last step, cube root both sides. This will be cube root of 4x minus 12 equals y. And we don't need to put a plus or minus unless it is an even root. This is one you should be able to do on your own. Pause the video, do this one. When you unpause it, I'll have the solution up here. Here's the solution. Since this was an even root, you do need to put a plus or minus in front. And number 11, we have this little qualifier. They're telling us that x is going to be greater than or equal to 0. This matters because if x is less than 0, if x was negative, then we would have to worry about the plus or minus. This particular problem, we don't need to worry about the plus or minus because they're telling us that it's automatically positive. We don't need to worry about the negative. So we do the same thing. This will be x. This will now be y. Switch x and y. Solve for y. I need to get rid of the 4 first, so I divide both sides by 4. So x over 4 equals y squared. Then square root both sides. Normally I would say put the plus or minus, but we don't need it. I can't take the square root of x, or square root of x can't simplify, but square root of 4 can simplify, which is nice because we don't want a root on the bottom of a fraction. Square root of 4 is 2. So I will simplify that, and it's no longer under the radical, but the x is. Alright. And then the final problem on this little section, switch x and y. This will be x, this will be y, and then this is all to the 2/3 power. We did this a little bit last unit. To get rid of a 2/3 power, we are going to raise it to the 3/2 power. It's the reciprocal. Those will cancel. Whatever you do to one side, you have to do to the other. This is the 3/2 power. X to the 3/2 is going to equal y minus 3. And then to get y by itself, we add 3 to both sides. So x to the 3/2 plus 3 equals y. That will be our answer. We technically could write this in radical form also if we wanted to. Remember to write this as a radical. I'm going to do it off to the side. It's going to be a square root of x to the 3rd. You can simplify that. X to the 3rd means 3 x's. There's a group of 2 x's, so this would be x that comes out, 1 x stays in. So you could also write this as x root x plus 3. I don't like that as much though. Really, I should probably put 3 in the front on that. I like the thing that I had highlighted better. You can just leave your answer like that. Alright, the function d equals r squared over 24 is a model for the distance d in feet that a car with locked brakes skids in coming to a complete stop from a speed of r miles per hour. Using the inverse function, estimate the speed of the car as it skids, that has skid marks 114 feet long. Dang, that was hard for me to read. Doing this one, I'm not actually going to switch D and R because I still want D to be D and R to be R. I don't want the actual full inverse of this function, but I am going to solve for R because that's what we want in this problem is R. So to get rid of the 24 on bottom, I multiply both sides by 24. So 24D equals R squared. And then to get rid of the squared, I square root both sides. Typically I would put a plus or minus in front, but we're talking about speeds and distances. We're not going to need to worry about negative speeds and negative distances, so I'm not going to put the plus or minus. Now that I have R by itself, I'm going to plug in the distance. So the distance of the skid marks was 114 feet. 24 times 114. And then I'll just type that into my calculator, square root of 24 times 114, and I got 52.3. And this, we're trying to find the speed, so that would be 54.3 miles per hour. So I'm going to write that as mph. Alright, that is it for this day. Yeah, thanks for watching. Have a good one.